inverse functions, and this you can find on your PowerPoint, but I'm going to continue on with it. From here, I gave you 3 examples. The first one was that I did yesterday was a straight line equation. So you had A, and I showed you how to find the inverse function. Now, I want you to have a look at how to do B, and then how to do C, and then once you understand that, we'll then talk about piecewise functions. Okay. So B, if they ask you to find the inverse function for each one. What I want you to do, this is an exam question, I want you to start off by looking at, again, remember the domain of your function is equivalent to the range of your inverse function. And right now they already said x is greater than 5. So they're already telling you your domain is from 5 to infinity, but not including 5. That's what you should have taken out from that symbol. So that means that tells you that your inverse function has a range, because it asks you for domain and range. You already got the range just by looking at that symbol there. So you're saying that if your domain is 5 to infinity, therefore your range of the inverse is 5 to infinity. The only thing you don't know yet is what is the range of this function. Okay, and you can do that just by sketching that graph. And that's why I was saying chapter 4, if you knew how to sketch this rectangular hyperbole, you can actually just find out what the range is. So I'll look at that and I know the range is all real values except for 0. Okay, and that's because I can picture the graph, I can look at that and it just tells me it's moved to the right by 5. Okay, so this is telling me if you solve that, that's right by 5. Okay, right by 5, and that negative tells me it's reflected in your y-axis. So therefore your graph of f of x should look like this. It's moved to the right by 5, and it hasn't moved up or down, so it's still at y equals 0, x equals 0. Notice I'm labeling my asymptotes. I notice a lot of year 11 students don't do that. It's okay to just draw it, but you also have to label it the way I did. So label, don't write just 5 here. 5 is not good. Okay, you'd actually have to write x equals, that's your equation of the asymptotes. You have to write x equals to 5 and y equals 0 at the end of that. Okay, and I know it reflected in the y-axis, so it actually looks the other way. And this is what I know. That's what it looks like. And because I know that's the shape of the graph, that's why it makes sense. But then they said domain is 5 onwards. That means this doesn't exist, because they said only from 5 onwards. If they had said the domain was all real values, then yeah, you would have had this side, but they said from 5 onwards. So that means my graph only has the bottom section, and you do not have the left half. Okay, so normally you would have sketched your hyperbola, but that's why I'm saying the domain matters. You said the domain is only from 5 to infinity, so I'm only including 5 into infinity. I'm not including when it's 4, I'm not including when it's 0, otherwise I'd have a graph over here. Okay, so this is my graph. And so I look at that now, I can say, okay, that means my range now is all from negative infinity all the way, so negative infinity, all the way up to 0, but you don't include it. So I know my range of my function is equal to the domain of your inverse, which is equal to 0 or negative infinity up until 0. Now this is another notation I want you to notice as well. I always write the small numbers on the left and the larger number on the right. It's not okay to write 0, negative infinity, and switch those two. Yeah, because in my year 12 I did the SAC and I saw some students do this. They had 0, x, or actually it's the other way. They had it like this. Like that. Technically it reads in a similar way. It's just this is saying, though, the difference is this is saying 0 is bigger than x and x is bigger than negative infinity. But what we really want to say is we want to say x is between negative infinity to 0. So x is larger than negative infinity and x is less than 0. That's what we want to say. So this still works, but they will penalize this in year 12. Okay, so I penalize my students for writing it like this. Okay, that's wrong, even though it technically means the same thing. Right? So now that I've got my domain and range, I've answered the question domain and range. I know my domain of the inverse function is this. I know the range of the inverse function is 5 to infinity. Okay, so therefore, now I just need to find out, well, Let's find the inverse equation. And this is how I want you to do it if it's in your exam. Okay, in your exam, if you had to find out the inverse, notice is in terms of g of x. Okay, so that means your final answer has to have g of x. If you're going to use y, that's wrong. Okay, so you can use y to help yourself to make it easier to solve. So for example, I'd say, you know, like swap the x and y's. That's the first step. Swap x and y to find the inverse. So that means this is your y value, this is your x value. I'm going to switch those two. So now it becomes x equals to 1 over 5 minus y. And your goal is to rearrange it so that you get y by itself. Again, this is back to algebra again. If you don't like, remember I said if you don't like the fraction, get rid of the fraction. It's okay to multiply both sides by 5 minus y. There's nothing wrong with that. Okay, so that's what I'm going to do. I'm going to say, all right, I don't like that denominator. Inverse of divide is times. So I'm saying times by 5 minus y, times by 5 minus y. Cancel that because they're 1. 5 minus y divided by 5 minus y is 1. So you're now left with equals to 1 on the right-hand side, and left-hand side you now have 5 minus y times the x. Okay, divide both sides by x. You get now 5 minus y equals to 1 on x. And you almost got y by itself. So now you can say minus 5 on both sides because that's a plus 5. You get negative y equals to 1 on x minus 5. And divide both sides by negative. You get negative 1 on x plus 5. And this is what I'm saying. You can't leave your answer like this. Okay, don't leave your answer like this. This is wrong because you started off with g of x and you're looking for g inverse. Why would that make sense? Where'd the y come from? Okay, logically that doesn't make sense. So your final answer should actually be written not like this, but it should be written as g with a negative 1 of x. That's g inverse is equal to 1 on x, negative 1 on x plus 5. That is your correct way of writing it. Now, if you want to extend this for next year, for year 12, what we would then do, if they said define, okay, right now it just says find the inverse, but if they say define a rule, use a rule, or determine the rule for the inverse, what you're meant to do is write with function notation. Now, if you remember function notation, it starts off with a letter. So in our case, we did g inverse, semicolon, you state your domain. So my domain of my inverse, which I found out over here, that's my domain of my inverse, which is negative infinity to 0. So I'd go negative infinity to 0. Okay, or you can do r negative, that's the same thing. Maps onto your code domain, which is r, all real numbers, comma, g inverse of x equals negative 1x plus 5. That is your proper way of writing it next year. So next year, the first few exercises, that's what you're doing. You're learning to define it using this. And see, in this one, you technically given the students or anyone who reads it, you tell them what you've restricted it, and therefore they can find out the domain. So if you type this in your calculator, it'll sketch it properly. It'll sketch the inverse with the restricted domain. And this is the function notation you've got to get used to. So you're using inverse, using the letter G, domain, code domain, inverse function. So it's all the same way, it's just one neat way of writing it all. And instead of writing it like this, in all 3 different sections, that one describes it all. Okay? So that's how you would do it in year 12. If you can get into the practice now, I would actually like you to do it that way. Okay? Otherwise, it's fine to answer the inverse function, which is here, and then state what the range of the inverse function, domain of the inverse, and the range. That's perfectly fine. Cool? All right, let's do another one. I did all of them. How about that? Let's go. All right, next one, h of x. Okay, now we're going to do it all again. Same thing. Is your domain. That's my domain. So domain of f is equivalent to the range of your inverse, which is equivalent to x is greater than or equal to 1. So it's from 1 to infinity, not including. I've got my range. Let's sketch this. Okay, so I've got my domain. Let's sketch this idea. So I've got an x squared graph minus 2, So minus 2 would be from here, negative 2. This is what it would normally look like. But be careful because you restricted the domain. You restricted the domain. You said it's only from 1 to infinity. You didn't say sketch the entire thing. So now you actually have to find out, well, where is 1? When x is 1, where is my y value? Okay, so you think about it. H of 1 is equal to 1 squared minus 2. I'm just subbing it back to the equation. Gives you negative 1. So that tells me when x is 1, y is negative 1. So I'm actually sketching it from here onwards. That means anything in red right now, you don't sketch. Okay, so that means if I were to sketch this, I shouldn't have that section there and that section there. That should be the only part of my graph that I'm talking about. Okay, because you restricted to the domain. It's said from x is greater than or equal to 1. So I'm going from greater than or equal to 1, my x values will have this. So from here, I can already tell you what my range is. The range was at negative 1. It goes away to infinity. So it keeps going up. My y values go from negative 1 up. And so therefore my range, answering the question, I'm just going to draw it neater. So starting from here, you can see my range is all of these values here. So it's negative 1 to infinity. And therefore range of your function, which is the domain of your inverse, is equal to negative 1 to infinity. Okay, so I've answered domain, answered range. To find the inverse, this is perfectly fine. You can switch the x and y, so I'm going to write it again. Switch. You don't have to write this in your exam. I'm just writing it for you. Okay, so switch x and y to find inverse. So if I do that, that now gives me x equals to y squared minus 2. And this is much easier to do than before because it's not a fraction. Add 2 on both sides. And you get x plus 2 equals to y squared. Square root both sides because it's a square. And you get y equals to root of x plus 2. Now, in year 12, you've got to be careful here. You've got a plus and a minus when you square root. So the question is it a negative or is it a positive when you square root? Because when you sketch the square root function, it could either be the positive or it could be the negative. So what I want you to do is you think about the domain and range. So the domain of the inverse is from negative 1 to infinity. The range is what dictates it. So the range dictates that it's from 1 to infinity. Because it's 1 to infinity, it has to be the top half. It can't be the bottom half. If this was negative 1 to infinity, then it would have been the bottom half. Okay? And that's a tricky part, because in year 12 there was a test on that, and a lot of students missed out on that. Even though they got the range and the domain of the inverse correct, they didn't realize that it could have been plus or minus, and you have to choose the correct one. Okay, so given that the range of your inverse is equal to 1 to infinity, it makes sense that it has to be root of x plus 2. Okay? Whereas if it was from negative 1 or negative infinity up into 1, then you know it's the bottom half. Okay? And so that's from 1 to infinity. And therefore, you don't write your answer as y. Finalize your answer. Your answer should be written in function notation. It's h, so it's h, inverse semicolon. Domain of your inverse, which we found out over here, negative 1 to infinity, maps onto R, and h inverse of x equals to root of x plus 2. You don't have to put the positive sign because by default that is the positive sign. Okay? Does that make sense? Yeah, so if I had to draw that graph, it just means it's a square root function where it shifts to the left by 2. And wait, is it shift to the left by 2? Yes, it is shift to the left by 2. So it will just be over here. And looks like that. Okay. Cool, but obviously you have to then restrict the domain. The domain would have been from 1 to infinity, negative 1 to infinity, so it would have been up here. So the graph would actually look like this. Let's do another color. Let's do green. It would have been -1, 1, so -1, 1, like that. Okay, so it's like a mirrored image if you reflect it along the y equals x line. Cool. So like I know this is quite tricky in terms of what you have to do. There's a lot of theory here, so you have to understand what a function was. So if you did a vertical line test for both, it's a function. Yeah, so that's why it's called an inverse function. Number two, you have to understand restriction of domain. What does that do? Pay attention to the range, and therefore when you write your answer, you have to be very careful with the domain when you restrict it. Okay, so that was exercise 5G, I think it was. No, 5EF, 5F and G. That's what inverse functions are. So if you can do inverse and you can do it all correctly, it means that you've understood domain, range, what a function is, the types of functions there are. Okay. If you can't do that, go back and make sure you understand those. Okay. Now, let's do a piecewise function. Piecewise function's really straightforward. So if you understood what I was just teaching you just now, a piecewise function is literally just playing around with restricting the domain. So for example, if I had a graph, let's say there was x squared. True? Let's say I had another graph. Let's say I did plus 2, x plus 2. Okay? That's my graph. What I can do is, what if I said I just want for the x squared graph, let's say I only want it from when x is equals to 1. So I only want to sketch from x equals to 1 onwards. Okay? Then what I would do is I'd say I want x squared, that graph, I want the domain to be x or greater than 1. That's what I'm saying. Okay, so that means I'm not going to sketch anything in the red part right now. I'm just going to sketch from there onwards. That's my parabola. Let's say from there, let's say I only want to sketch the straight line equation from where it hits the y-axis. So let's say I want it just from this point all the way down. That's all I want to do. Okay. Then that means in the blue line, this is what I'm going to have. So how do you sketch it on your calculator? We call this a piecewise because you're doing it in pieces. You're now saying, I want to sketch x plus 2, but I only want it all the way up until this value. That's when x equals 0. Okay, because when x equals 0, you get your y coordinate up here. So you only want negative infinity up until x equals 0. So I change my domain. For your graph, I'd say from negative infinity up until 0, and including 0. Okay, and this would actually scrap your straight line all the way up until 0, and then this would also graph the parabola up until x equals 1 to infinity. Okay, I want to show you with the calculator how I do that. So it's going to look something similar to the graph I've drawn, except the blue line would actually be a bit lower because it's 1. Okay, so it should actually look more something like that is what it's going to look like. Okay, so let's do that. Let's try what I just made up. I just made up that question on the spot. So let's have a look. I'm going to put in, add a document, add a graph. Okay, I go to your catalog, and I'm going to go to this box over here. Okay, because that's, you can type 2 functions in the one. I said I want an x squared graph, but I want x to be greater than or equal to 1. Okay, so I want just from there onwards. I only sketch that part. And for the second one, whoops. Oh, what happened? Let's do it again. So x squared, x is greater than or equal to 1. And this one was x plus 2. And I want it from negative infinity up until 0. Yeah, so I'm going to do that. Or technically, that's just x less than or equal to 0. So that's negative infinity all the way up to 0. Yeah, so that's called a piecewise function. I've got a quadratic and I've got a straight line equation. If I sketch this, that's exactly what I just told you before. You see, that was just your quadratic, and you chopped off that part because you said from 1 onwards, which is that part. 1 onwards. And I said for the straight line equation, when it's x plus 2, I'm chopping it right here. When it's all the way up to x equals 0, it stops. So there's a gap between 0 and 1. Okay? And so all you're doing in that exercise, 5E, is they're going to give you a bunch of questions. So if I just go back, you can see all they're doing here. You see all they're asking you to do, sketch this graph when it's greater than or equal to 0. Sketch that graph when it's less than 0. So you're sketching 2 graphs. So just make sure you're sort of drawing it correctly. So if I had to do this one, see for me, you got x, graph of x greater than 0. So this is where 0 is. So if I had to sketch it, that would be y equals x. And then if I had to then sketch my second graph is negative x for less than 0. So it has to look like that. And together, there you go. So let's test that. If I go back to my calculator and I did the same thing again, it was greater than 0, and this is less than 0. And that was x. Oh no. Oh, whew. No! Oh no, do I have to do it again? Yeah. Okay, negative x, 0, less than 0. There you go. That's my graph. Okay, so all you're doing is sketching the exact same graphs. All you're doing is reading the domain. Okay, so the first few questions are pretty straightforward up until you get to these ones. There's 3 of them, and you just draw them. But all I want you to take out of it was domain restricts part of the graph that you want. That's all you have to understand. Okay, so if you understand the restriction of domain, you don't have to do all these questions because it makes sense. You can even just jump in and do 4a. Okay, so if you just did 4a, just look at it, draw a quadratic graph, x squared plus 1, but only x greater than 0, and then 1 minus x for x less than 0. So for me, see when I look at that, I can already see x squared plus 1 looks like that for x greater than, and then that's what it looks like. Okay, so straight line and a quadratic. Okay, so that's all you're doing. So that's pretty much chapter 5 for you to take in. So inverse functions, domain, that's a very key word. You have to understand what domains are, restriction, and then notations, how to read the notations, and what is a function. Those are all the things you have to understand for chapter 5. Cool? All right. I know it feels a bit rushed, but the reason why is because I do want to get onto revision ASAP. So starting from tomorrow, tonight I'm going to post up some revision sheets for you guys to do. Okay, and you can print it out at your own time to do. But it'll be on Schoology, and these video recorded so you can go back and listen to what I was saying about domain, range, inverse functions. Okay? All right, and then we've got what, tomorrow? And then I don't have you Tuesday, but I have you Wednesday, and I have you Thursday. So that's 3 sessions that we can do for revision. Maybe we can split that up into like quadratic cubics in 1 session, and then we do probability and graphs and functions.
So we don't have a second list?
No, I'm going to put it all on Schoology, and you do it at your own time with solutions up there too. Yeah, but you have to have it.
We have a day off on Tuesday, though, don't we?
Yes, that's why it's Wednesday, Thursday, plus
Do we have
Wednesday.
the Macbeth thing on Wednesday?
Yeah, but apparently session 1 or 2. Yeah.
But when we have to hand in the take-home assignments?
I'm not going to really look into it until like the end of the week or so, like end of the term.
Oh, right. Yeah. So we've got to the end of the term.
Sorry?
We've got to the end of the term, like after the exam as well.
Yeah.
Oh, yeah, we have a day off.
Okay, so I'm going to end the video